Problem 9 states, how many different license plates can be made using 4 digits followed by 2 letters, if repetitions of digits and letters are allowed? Okay. So, first of all, we're choosing from 2 sets. We're choosing from the digits and we're choosing from letters. So, we're choosing from 2 sets and we're choosing from both of them. So that makes it overall a multiplication problem. The number of ways we can choose the 4 digits times the number of ways we can choose the 2 letters. Now let's examine those individual selection problems. How many different ways can we choose 4 digits? Well, in the first part here, they're saying that repetition's allowed. So if repetition's allowed, that's just a straight multiplication problem. There would be 10 digits we can choose from. So every time we choose, if repetition's allowed, we still have 10 digits to choose from. So the first digit, there are 10 choices. The second one, there are 10 choices. The third and the fourth. So we basically have 10 to the 4th power, which is 10,000. That's how many different ways we can choose the 4 digits if repetition's allowed. And the same way with the letters. If repetition is allowed, when we choose the first letter, we have 26 choices. When we choose the second letter, we have 26 choices because repetition is allowed. So if we take the product of those numbers, that gives us the nice big number of 6,760,000. So that's how many different license plates we could make. Now that's actually a practical problem. Somebody has to figure that out. Figure out a way, figure out how many different license plates you can make when you have to make license plates to issue them for a state. And depending upon the number of vehicles, registered vehicles, that may not be enough license plates. So you might have to expand that to 3 letters, which would give you then, what, 26 more times that? Well, the second part of the problem says, if repetition is not allowed, well, overall, it's still however many ways we can choose the 4 digits times however many ways we can choose the 2 letters. But now, if repetition is not allowed, then we can view that as a permutation or combination type of problem. And in this instance, it would be a permutation because the order is significant. A 2 followed by a 3 is different license plate than a 3 followed by a 2. So even though you use the same 2 digits, it'd be a different license plate. So we can view this as a permutation of 10 things taken 4 at a time times a, same way with the letters, permutation of 26 things taken 2 at a time, which is going to give us 10 times 9 times 8 times 7 times 26 times 25. And when we do those multiplications, we end up with a value of 3,276,000 different license plates that we could form. And another way to view that is in each of those choices, the first digit you choose for your license plate, you have 10 choices. Then, since you can't repeat any of those digits, the digit you chose, I should say, you only have 9 choices for the second digit, only 8 for the third, only 7 for the last digit. Same way with the letters. The first letter you choose, you can choose any one of the 26. Then once you've used that one, since you can't repeat them, you only have 25 choices left there. So either way, whether we just view it as those multiplications or view it as permutations, we come up with that same number of license plates we could make if we're not going to allow repetition in the license plates.